Okay, so this is the solution to the last IB question on your sheet. Like I said, like I mentioned before, the first one I didn't do, but we've done the first three, or sorry, the next three, and now we're going to do the last paper one question. So reading through it, it says, show that the point 0, 0, and, so I'll write P1 of 0, 0, and P2, well, whatever, we'll pretend that's a P, I drew an R, but root 2 pi and negative root 2 pi on the curve, and then I'm going to write e to the power of x plus y is equal to the cosine of xy. And they have a common tangent. So obviously I hear the word tangent, the alarm bells go off in my head. I need to differentiate, and unfortunately I've got x and y, so I know there's going to be some implicit differentiating there, but that's okay. So this first part is easy, right? The derivative of e to the power of something is just itself. And now I have to take the derivative of both of these, but it's nice and easy because it's just addition. So it's multiplied by, what do I have here? 1 plus dy dx for my first occurrence of implicit differentiation. And now cosine of xy is going to be minus sine of xy, and then using the product rule to differentiate the inside of my bracket, and I end up with x dy dx plus y. Okay, so now all I have to do is plug in my set of points. So first I'm going to branch it off. I'll do one set of points here, one set of points here. So let's start off with x is equal to 0, y is equal to 0. So when I have x is equal to 0 and y is equal to 0, 0 plus 0 is still going to be 0. So I'm going to have e to the power of 0 times 1 plus dy dx is equal to minus sine of, well, 0 times 0, which is still just going to be 0. This is going to be 0 times dy dx plus 0. So all of this is just equal to 0. So it's equal to, I don't even know why I wrote the minus. Let me wipe that out. So it's just equal to 0. And now I can solve this. Obviously, e to the 0 is just 1 times 1 plus dy dx, opening up my bracket, isolating for this, so I move the 1 over to the other side. Dy dx is equal to negative 1. So that's what I get when I plug in, my words are failing me now, when I plug in 0 and 0. Now let's try the same thing. Let x is equal to the positive root of 2 pi, let y be equal to the negative root of 2 pi. So again, plugging in all my values. So I'm not going to skip any steps. Obviously, if you're comfortable with the algebra, you can, but I don't want anyone to get confused. So this is going to become e to the power of root of 2 pi, but then minus the same value. So that'll eventually simplify to 0. And here, I just have 1 plus dy dx, nothing to plug in there, is equal to the negative sine of, what do I have here, minus 2 pi, right? The roots cancel out, so the root cancels out when I multiply, the negative's still there, and I just have 2 pi multiplied by, oh boy, I might run out of room here, let me be very careful. I've got root 2 pi times dy dx minus 2 root pi. Now don't worry, I know this looks like it's going to be ugly, but we notice here sine of 0, sine of pi, sine of 2 pi, and going backwards, sine of negative pi and negative 2 pi, this is just equal to 0. So then once I know that this is equal to 0, it's kind of irrelevant what this bracket is, because it's just going to be 0 times something. So the entire right side of my equation becomes 0, And now I just have to solve this. Positive root of 2 pi minus root of 2 pi is going to be 0. So this will be e to the 0 times 1 plus dy dx. And at this point, we still have a little bit more algebraic justification to go forward, but the equations already match. So we already know they're going to be equivalent. So I get 1 plus dy dx, sorry, maybe be a little more clear, is equal to 0. Dy dx is equal to negative 1. So we have a common tangent, right? Since both points lie on this line, since both points are on y is equal to negative x, there is a common tangent, right? And I can jump to this conclusion because that's where these points are, right? Essentially, no sane human being writes 0 and negative 0, but that's what this is, right? It's our diagonal line that passes through the origin. Our first point here is 0, 0, so over here, and then here I've got 2 pi, what do I have here? 2 pi and negative 2 pi? Oh, I drew the wrong line. This is what happens when you do math when you're really sleepy. So it is y is equal to negative x. That's why I was being thrown off. So my first point here was at 0, 0. The other one was at positive 2 pi, root of 2 pi, and then negative root 2 pi. Right? Equivalent in magnitude essentially, but one coordinate is negative, one coordinate is positive. Okay, so that's it for the 4 IB questions I posted solutions for. Even if you have more IB questions, I don't think I have it in me to stay up any later to do another solution. So hopefully these made sense. Again, if they don't, just skip them for now. Try the rest of the IB package. All the answers to the questions are posted, like the answer key is posted magnetically to the chalkboard at the back of the class. And yeah, I can answer any questions that we have from these questions Thursday in class. And if not, if you don't have any questions, you'll have a practice quiz to work on. So have a great day, and I will see you Thursday.